Look at how to use trig to solve for sides of a triangle. Let's start with the warm-up. A ladder is leaning up against the side of a building. It is 3 feet away from the wall and it goes 4 feet up the wall. How long is the ladder? Well, let's start by drawing a picture. I know this is a triangle. Alright, so we know that the ladder is 3 feet away from the wall. So if this is my wall, this is 3 feet. And the ladder goes 4 feet up the wall. And we're solving for the length of the ladder. I'll call that x. So if we have two sides of a right triangle, we can use Pythagorean theorem to solve for the missing side. So we have 3 squared plus 4 squared, our two legs. I know they're legs because they're connected to the 90-degree angle, equals x squared. 3 squared is 9, 4 squared is 16, equals x squared. 25 equals x squared. We can take the square root of each side. So the ladder is 5 feet tall. So we can use Pythagorean theorem to solve for a missing side of a right triangle if we already know two sides. So the next question is, could you use Pythagorean theorem to solve for the following problem? This time we have one of the legs is 7. We don't know the hypotenuse, and we don't know the other leg. So we can't use Pythagorean theorem to solve for this problem because we only know one side and we're missing 2. So our goal today is to learn how to use trigonometry to solve for a missing side. So there are different parts of a triangle. We always start with the angle that's not the 90-degree angle. So in this case it's 35. And there's 3 sides that we're going to assign in this triangle. One is the hypotenuse. We already know that one. It's the longest side. But now with our angle right here, there's one side opposite the angle. So I'm going to call this side O. And there's one side adjacent to this angle. So this side is called A. So again, this is the hypotenuse. One side is opposite the angle. That's not the 90-degree angle that you're looking at. And this side is called the adjacent angle. Adjacent means right next to our angle. The side that's right next to the angle, that's not the hypotenuse. So O and H, opposite, adjacent, and hypotenuse. And so we have this little saying SOHCAHTOA that helps us set up the ratio to solve for a missing side or angle. So so means sine. So sine of x equals opposite over the hypotenuse. So that's so. CAH, ca, cosine, is, COS is cosine, the abbreviation for cosine. And that's the adjacent side over the hypotenuse. And the last side here, TOA, TOA, tangent, of our angle is opposite over adjacent. So we're going to use these ratios to help us solve for a missing side if we only know one of the sides. So here are the steps right here. Circle the angle that you know. Never use the right angle. Identify opposite, adjacent, hypotenuse sides. Use your sides to figure out if you need sine, cosine, or tangent. Set up your ratio, cross multiply, and solve for the missing side. So we're just going to do 5 examples together, and we'll practice today and tomorrow. So first, identify your angle that's not the 90, and see which sides you have. Here's our angle. This side is the hypotenuse. I know that because it's across from the 90. The other side's opposite our angle, so we have O and H. So then again, think about your ratio. We have SOHCAHTOA. So look for what we have. We have O and H, so that's sine. So we're going to say, all right, sine of our angle, 40 degrees, equals opposite over hypotenuse. And then we're just going to cross multiply and solve. So we have x equals, let's go this way first, 15 times the sine of 40. And then we just type that in our calculator. So we have 15, oops, I should give myself a calculator page here. The trig button here is next to the number 7. There's sine of 40. We get 9.64. 9.64. And again, our leg should be smaller than our hypotenuse, which it is. All right, let's try the next one again. Circle your angle that you have the 20 degrees. Again, we have the opposite side here, but this time we have the adjacent side, the two legs here. We don't have the hypotenuse, which is the longest side. So you look at your trig ratios, which has O and A, and it's tangent. So we're going to say tangent of our angle equals opposite over adjacent over A. And again, we cross multiply and solve. We get x equals 14 tangent of 20. And then you just type that in your calculator. 14, use the trig button, tangent of 20. And we get about 5.1, I'll put. So x equals 5.1. All right, let's try the last one. So again, circle your angle. That's not the 90 here, it's 37. Again, we don't have the hypotenuse. We have the opposite side. We have the adjacent. Let's write this up. So again, it's tangent, opposite and adjacent. Tangent of 37 equals opposite, which is 24, over adjacent, which is x. We're going to cross multiply and solve. We get 24 equals, this time we have x, tangent of 37. So see if I can squeeze in there, 37. And to get x by itself, we have to divide by tangent of 37. So in this case, we'll take our 24, we'll divide by tangent of 37. And we get 31.85 all round to. Is our answer. So this picture is not drawn to scale. Okay, let's try a few more. Okay, so we have D again, circle the angle. We have 33 degrees. We have the opposite side. Again, we have the adjacent side. So again, if we look at SOHCAHTOA, we have tangent. So we're going to write tangent of 33 equals x over 11. We'll cross multiply. X equals 11 tangent 33. Type that in. 11 tangent 33. And we get 7.14. And the last one, circular angle. This time we have the hypotenuse and the adjacent side. So this one is cosine. Cosine of 25 equals adjacent over hypotenuse. We cross multiply. We get 14 equals x cosine of 25. To get the x by itself, we're going to divide each side by cosine of 25. This here. So these cancel. And let's type that in. 14 divided by cosine of 25. And we get 15.4. So here the hypotenuse, or x, is 15.4. So again, the steps are on your worksheet. You circle your angle, you label your sides, you pick your ratio, and you cross multiply and solve.